Good morning, everyone who is online. It's a privilege and honor to be presenting on the CII platform on this very important green cement tech webinar. Over the last, yesterday we had our industry leaders presenting the vision up to 2050. Both from an industry perspective as well as from an environmental perspective. And we had the technology leaders, which we have heard even among our panelists, presenting the various technologies for the future and currently to help us reduce our energy consumption. Right, but for an industry, for a plant perspective, how do we go about doing whatever our leaders ask us to do? That is a key topic that we'll be addressing through our services in SRSMES. SRSMES, we are a 9-year-old company. We have a small boutique consultancy. We have done up to 120 process audits across all the OEMs who are presenting in this seminar and those who have not presented. We have experience of system audits among all the OEMs. We have so far executed almost 26 projects across the spectrum of all the sections of the cement process. We are basically into cement plant design and engineering, plant audits, cement plant consultants services, modernization and upgrades, training and development, process support services, NOx, WHR systems with HAR, alternative fuels and CFT. That's what we are. And me, Vijay, I have 40 years of industry experience. I've worked with ACC, Blue Circle, Lafarge, Holcim for almost 25 years abroad. In the field of process engineering, projects, technical support, business management, etc. Currently, I'm working with SRSMES. What do we bring to the table? Before we speak about it, let us look at the net zero challenges. What is the magnitude of the task? You know, yesterday we have listened that in India, we have 3 types of plants. One, which are very progressive, leading the initiatives to energy, net zero initiatives. Then there are plants which are just waiting and watching. And then there are plants which are just saying, I don't care or I don't know. So we have a spectrum of approaches among the various industry plants. In addition to that, as one of the biggest producers, we have 210 large cement plants, almost 550 million tons. So the impact is quite huge. But along with the challenge is that almost 50% of the capacity is almost 20 years old. That's, you know, built in 80s, 90s, etc., where it is not, they are not designed for the kind of fuel mixes and product mixes that we want to produce over the next 5, 10, 15, 20 years. As yesterday GCC was mentioning that unless we do kind of an upgrade and utilize these technologies in 10 years and make it happen, it may not be possible to reach the net zero ambitions. Currently, we are only at 70% of utilization. So still there's the 200 million tons of capacity that needs. And we have the challenges of various technologies. You know, the European ones which we have been listening from the panel is the Chinese, the Indian, and various other low-cost countries. From a fuel perspective, unfortunately in India, we are quite low in the overall utilization, only 4%. The benchmark figure that the CII has produced, you know, the numbers that we see, only 10 to 15% of the plants are really at that particular global best performance. The rest of the plants are still to catch up, and that requires high investment costs. And yesterday we heard about high interest rates, lack of capex. So how do we facilitate a solution with lean capex while meeting the environmental needs, the profitability of the business, etc.? Now the challenges, here we speak of only scope 1 emissions of the net zero. That's what the plant produces, mainly around specific heat consumption, power, alternative fuel, waste heat recovery. The bulk of the challenges, as what we see based on our experience auditing the plants, operating the plant, the older plants are not designed for high AFR. They are not designed for high TSR. The fuel variances last year and this year has given a very good shock for the industry, where there is a high variance of source, quality, and prices. Where yesterday Mr. Singhania was mentioning the cost of energy in the cement production has gone up from 800 rupees to 2,000 rupees per ton. That's the kind of a challenge from a business perspective. Then there are technical perspectives that we have to address. So as a service provider, what do we bring them? And what do we see? We see intraday variations, day variations, and seasonal variability. While the yearly performance shows quite a consistent number, surprisingly, when we audit the plant, we do find a lot of variabilities. We do find reliability issues, productivity issues. Then we find difficulties. We have lot of new technologies, modern technologies that are bought at a very high cost. Are we able to operate them consistently, etc.? If we are not, then we find significant gaps in the operational systems. Then from a team and skill perspective, most of us are basically production oriented rather than process or system oriented. That are the challenges that we see on this one. Now if you look at where do the Indian plants stand, there is a lot of things to catch up, even among the best. The variable, yesterday's CII presented almost 115 pages of benchmarking. Because you can see, even on the top, there is a lot of variability. On the alternative fuels, there is a lot of catching up that we need to do. So what is our methodology of navigating our clients? When the clients ask, what should I buy? What are my requirements? What is the kind of a technology that would suit me? Would it fit into my plant? And what are the real gaps from a business perspective and a technical perspective? What we see is that we have to audit. That is the first approach. Then we do the process adjustment. Then we look at the optimizational part of it. Then we retrofit, and then if required, replace. That is our methodology we look at it. For example, if we look at the specific heat consumption, what we see in our process audits, we have three different cluster or types of plants that we say. The plants which are old, with a high heat consumption, which are needing optimization and upgrades with retrofits. Most of them are older than 20 plants. Then there are very modern plants which are running to full capacity, very good heat consumption, etc. But they are ready for the newer technologies, artificial intelligence, and various other things. Then there are plants that need optimization and SSC evaluation, retrofit. Here what we find strange is that some of these plants display highly consistent specific heat consumption irrespective of their capacity utilization. That gives us a requirement to evaluate what is the real heat consumption that they have. And until we evaluate the real heat consumption, we cannot recommend retrofits. Then we also see, when we evaluate and recommend retrofits, it's not an audit of 1 or 2 days of site visits and audits. We look at the historical data and to see how is the long-term deterioration or consistency of performance of these plants. If there is a long-term deterioration in productivity, we need to address this thing. Similarly, on a very short term, we find intraday variations. Mostly what we get from a plant is that, this is our average fuel consumption, average power, etc. But when we look at the opportunity, when we want to look at the opportunities and the reasons and what adaptability of a retrofit, we look at much more closely. We look at the intraday variations of operational KPIs that are impacting the capacity or the heat consumption or the power consumption, etc. So similarly, on the specific power consumption also, what we see is that there are large variations, especially on power consumption around me and etc., which are we see a large variation up to 20%. Imagine a large 20% intraday variation. It has a huge potential for savings. And what do we do with all this data? People, when the plants ask, we need a retrofit, we need to buy in a new technology, new equipment, etc. We have our own designs, but we also supply, we work with all the OEMs to give the correct equipment to them. But before that, our solution is focused on first is the process fine-tuning, optimization, and then required, okay, you have done you have optimized your plant, then we look at the new technologies or new retrofits that will come into the picture. Now, from an AFR perspective, India, we have taken almost 15 years to reach 4% TSR. There are technological challenges, definitely, but there is also AFR usage impact. It is still not fully captured in India. At 5% substitution rate TSR, our productivity loss is hardly 1%. Our ambition is to go to 60% and 100%. At 60%, the productivity loss could be almost 7-8%. At 30%, it could be 7-8%. At 60%, the productivity loss could be almost up to 15%. So then a corresponding impact on specific heat consumption, the specific power consumption, that automatically increases. So that has an impact on all the equipment, in terms of fans, calciners, de-dusting systems, everything, etc. In addition to that, from a technology, from an equipment supply perspective, we have to address the AFR variability. Most of the plants that have delivered a higher TSR in India have basically been able to get that because they were able to get carbon black. They were able to get dollar chart. But that's not all plastics. With the change in the regulations on the plastic, obviously the future is almost on RDO, refuse derived fuel, or MSW, etc. Then there is an issue of the type, the quality, the CV variations, and the moistures and the granulometry. Plus, yesterday Mr. Saxena was presenting, because the price of fuel has gone up, the price of AFR has also gone up. So so given this constraint where the quality is not really consistent, this is the next challenge that we normally encounter. Now, when we have only MSW, when we have audited a plant, this is a typical plant that we have audited, which was having almost 25% TSR. In the intraday variability is quite high. The quality and the high moisture content. Mostly what we see is that when we are looking at TSR, this is one thing that we do not really control. That's the moisture that we are firing into the game. It has a significant impact, right? Normally MSWs in India, we are getting almost 30-35% moisture. And that effectively, even though we say that we are at TSR of 24%, the effective TSR becomes almost 10%. That has an huge impact on the specific heat consumption and the gas volumes and the flame temperatures. So obviously it basically reduces the capacity of the calciners, burners, the process fans, etc., etc. So given that this is a challenge that will increase as we are targeting a higher heat TSR from 5% to 20 to 25% or higher. So what is the way forward? Obviously, the plants which are younger than 20 years, they're more designed with the calciners, etc. They can be optimized. They can do the new technology replacements, and they can accelerate AFR. And plants which are older than 20 years, first there is a need for optimization. Then the next thing that comes up into their retrofitting, because the AFR adaptation has to be slow. So what do we bring to the table? We assess the requirement of the client plans and need. What is their capability? Yes, the technologies are available. Does it fit into you? Does it suit you? Does it suit your raw mix? Does it suit your layout? Does it suit the various other fuels that you are using? The availability, the feasibility studies. Then the process design engineering for resizing, retrofitting, and replacement of equipment. What needs to be, what can be replaced, what can be resized, and what can be retrofitted. Then the selection and supply of equipment, which are needed for pre-processing. We also advise on the pre-processing equipment. What kind of shredders are needed? Do you need what you call the secondary shredders at this stage of a TSR? Do you need an AFR dryers? What is the requirement? What kind of a size fraction that we will be able to handle? We support on commissioning and optimization. All right. On our experiences, I just shared the projects that we have completed. We have done quite a few upgrades, varying between 3,000 to 6,000 TPD across all the OEM plants that we have, that we project, major FLS, KD, polishers. Most of the plants we have retrofitted. Currently, we are doing 3 projects. 2 projects at Dalmia, we are upgrading that kiln from 5,500 to 7,000 TPD with 35% TSR. We are also doing one upgrade in Kazakhstan, 2,400 to 3,000 TPD without calciner. It's a mix of various jobs from cyclone replacements, calciner modifications, and the whole pyro system upgradation, including cooler upgradations as well. Similarly, on the grinding systems, we have done a lot of retrofitting jobs across all the major OEMs mills, from Lucia to FLS to Thyssen, Pfeiffer, Walchennagar, etc. We have done coal mills, raw mills, cement mills, etc., with significant savings in power consumption. Currently, we are upgrading a project in Kazakhstan, which is on closed circuiting of cement grinding systems. All right, we have a repeat orders also on that. All right, on the process audits, as I mentioned to you, we do the process audit. We have an experience in 9 years. We have done 120 audits, roughly audit a month. That's our experience. We have audited plants from 1,500 TPD to 10,000 across all the OEMs. All right. And these reports, we have experts who have not only designed and commissioned plants, but experts who have run and operated plants. So we get better operational perspective than some of the OEMs which provide the technologies. All right. We also do hot air recirculations on the waste heat recovery. We have done 5 projects completed across UTC, LJK, and others, and across all the types of coolers, from FLX and IK and etc., with significant savings, right up to 0.5 megawatt. We have ongoing projects in 3 plants in Ultratech, Dalla, and Rajeshri. We also have done alternative fuels for Narmada, firing systems up to 10% AFR. On the waste heat recovery, we have done the waste heat recovery with the new AKC boilers, etc. So we have a spectrum of solutions where we work our own internal process designs as well as with the OEMs. Overall impact, at the moment, as we say, we are young, but we are leaving a significant impact. As of today, our customers are saving roughly 65,000 tons per year of CO2, almost 27,000 megawatt of power every year, and roughly almost 1.3 trillion kilocalories of power savings that we have brought to our customers. Right. For any other inputs, I'm available, and you can have a look at our website for further details. We'll be happy to serve you. Thank you.
Thank you very much, sir. Thanks for sharing your rich experience and then also highlighting the various opportunities available in the plant and then the opportunities available in the existing plants to upgrade them to meet the current challenges. Thank you very much, sir. We will post any query or this thing from the participants, and I will also share your contact details with them.